Current trends in outdoor recreation have created unsustainable demands on our public lands and roads, and the COVID-19 pandemic has only exacerbated the problem as the population looks for new ways to recreate in outdoor situations. As a result, we are rapidly degrading natural resources and experiencing unattainable levels of trail use, traffic, and infrastructure strain. Historically, the tools land managers have used to track outdoor use have included such things as counting trail users by hand, parking lot vacancy rates, how often the toilet paper needs replacing at a trailhead, or how frequently pit toilets need to be pumped. But all these tools measure land use by looking backwards in time. This can result in strikingly divergent predictions of future use across various land management agencies. The Intelligent Recreation System, also known as IRiS, looks to change this by conceptualizing the capturing of dynamically produced data such as location-based services, social media, and website metrics. IRiS provides land and transportation managers with new tools for measuring and managing recreation demand. Using machine learning and/or artificial intelligence techniques to analyze these large and diverse datasets, land managers and policymakers can then quantify recreation demand before it hits the roads and trails. With this information, strategic interventions can then be applied to balance recreation use in real time by nudging land users to recreational areas which are less congested.
Thank you, Jose, for the overview of the problem we are trying to solve, as well as a brief description of our solution. My name is Todd, and together with Jose and Aklam, we are the development team tasked with implementing the Intelligent Recreation System for David Levy and Mobility Next. The Intelligent Recreation System is divided into two key elements: the land user or public-facing section and the land manager/policymaker section. Each section is designed to work seamlessly together with the other section to achieve the desired goal of managing resources in a real-time dynamic way and achieving a sustainable balance of recreational use on public lands. At the core of these two sections is the synergy of two key statistics attached to each individual trail: the current score and a threshold. The current score is an aggregation of the datasets we are conceptually capturing. These novel datasets, which include such metrics as social media, mobile phone GPS tracking, and web content views, combine to give us the current score of a trail, which is a, quote, real-time depiction of recreational traffic a particular trail is experiencing. The higher the score, the higher the traffic is thought to be. On the other side of the equation is the threshold statistic, which is what land managers deem to be the carrying capacity or number of recreationists the land can sustain at each individual trail. While the current score is calculated by actual demand found on the trails, the threshold is manually set by land managers to nudge land users away from overcrowded trails. This threshold, combined with the current score, determines which trails are returned when users search for trail information on the front end of the application. Let's check out how this works. When a land user navigates to the application, they have two options to discover new trails. One, they can click on the Trail Display tab. Here they can click on a picture to get basic information about trails in their area. The second option a user can choose is the Trail Search page. When the user clicks into this page, they are immediately presented the closest trail to them contained in our database based on their current location. And most importantly, its current score is lower than its threshold. On this page, users can search for specific trails. If a user searches for a trail whose current score is higher than its threshold, the trail is still returned, but the application displays a warning about the trail being projected to be over capacity, and the user is encouraged to check out similar trails, which are displayed on the right side of the screen. Our goal is not to hide trails or deny access to trails, but to have users make informed decisions about their outdoor recreation. Currently, the similar trails displayed are sorted on their proximity to the trail the user searched for and are similar in length. All of these similar trails on the right are trails whose current score is below its threshold. Another feature of the trail search function is the trail description. Here, a dynamically created description of the trail is shown with the wording of either lightly trafficked, moderately trafficked, or highly trafficked based on the current relationship between the trail's occurrence score and its threshold. With these subtleties, the application tries to nudge users to less crowded trails, therefore not overwhelming public land resources. So that's the general idea of the public-facing part of the application. Jose will now take us through the dashboard, which was created to assist land managers. Jose?
Land managers across the board have been using a boots-on-the-ground approach, and IRiS is here to replace it. This platform can capture location-based services by tracking phone signals from land users. During times of limited budgets, this approach can replace trail counters who track visitors by hand. We are also able to track social media mentions, offline data, and content views. These novel datasets allow us to qualitatively come up with a unique score to each trail. This score is a representation of how busy we expect the trail to be on upcoming days, and the threshold is a similar score that land managers have full control of. This score allows IRiS to work with the implemented algorithm to nudge users away if a trail is over capacity. Let's get a quick demo. Let's say we want to change the threshold to 40, which means we are decreasing the capacity that that trail can hold. We commit the change, we get a notification, and the change has been made. Under trail scores, we see that the threshold is now at 40. As a land manager, I would also like to prepare for upcoming visitors, and with the use of machine learning, we are able to request predictions of upcoming visitors days ahead. Under Overview and Predictions, we choose a trail, operation type, and let's say we want to request a prediction for Wednesday the 5th. We request that, and we get a notification saying that we are expecting 108 visitors that day. That would be 28 more visitors than the last data point. With all of these features and more, IRiS is capable of making an impact on how public lands are managed.
Thanks, Jose, for walking us through the Land Manager dashboard. And that ends our presentation. On behalf of Auckland Desta, Jose Ramirez Casada, David Levy of Mobility Next, and myself, Todd LeBeau, we hope you'll find your next trail adventure using the Intelligent Recreation System. Thanks for watching.